Okay. Ray, Brandon, Kristen, Ashley. Tiffany? What else? Who else? Freddie, Kelston, Kimberly, Kristen, Mandy, Emmanuel said done. Very good. Celine is having a problem with logging in. She just texted me. Okay. All right. All right. You screenshot it. Celine, you screenshot it, my dear. Don't lose it. Okay. But you're in the dentist. How can you write it? Okay. So just keep it. And when you come back home, just write. Yeah. Okay. Now, don't think that geologists go to the field and say, okay, this is older than this. Why you say that? I'm Professor Sen of BCC. I teach awesome students, Ashley, Brandon, Celine, Emmanuel, Freddie, Kelston, Kimberly, Kristen, Mandy, Ray, Tiffany. These are all my students. So whatever I say, if I say this rock is old, then this rock is old. It has to be either my way or highway. No, it cannot go like that. So we follow certain principles. Now let us see what are the principles. This we'll be doing in our lab today. Okay. So please write it down. The first one is principle of original horizontality. Principle of original horizontality. Okay. Principle of original horizontality. Then the next one is principle of superposition. Principle of superposition. Okay. Please write down the name, then we'll explain each one. Principle of cross-cutting relationship, number 3. Principle of cross-cutting relationship. Number 2 is principle of included fragments. We'll come to more principles. Just write these 4 first. So we'll go over each one of them. Okay, if you have missed it, that's fine. You will see now we are talking about it. Principle of original horizontality. Students, according to the law of gravity, anything that falls on the ground should be one after another. When we pile up books, it's one on top of another, one on top of another. Okay? Now, if you see a rock which is tilted like this, and we have seen it in the field. When we go out in the field, we see rocks, they're tilted. One, it's tilted. Nobody has the time to take a huge mass of rock and tilt it. Nature has tilted it. When it is tilted, you have to understand that a tectonic process. Now you'll say, oh my God, Professor Sen, why are you using hard words? Tectonic means something related to the earth. Movement. Movement which cause earthquake. Movement which cause mountains. Movement which cause many, many things. Mountain building, earthquake, fault, fold. Those are all called, these are all called tectonic movement. So there was some kind of movement which made the rock tilted. So to me, I will say that the rocks were formed before the tilt happened. So now if I know this tilt is because of a movement for formation of this mountain, which was 50 million years old, to me, the rocks are older than 50 millions. Because the rocks are first formed, then the tilt happened. So the rocks are more than 50 million. Okay? This is called principle of original horizontality. Please write down the name of the principle. The principle of original horizontality, which states that every time a layer of rock is formed, it has to be horizontal. If you see the layer is not horizontal. If you see the layer is not horizontal and it is tilted, you have to imagine that the tilt happened after the rock was formed. Clear or not? Please write it in the chat and write the name of the principle of original horizontality. Clear or not? Thank you. Okay, good. Next is principle of superposition. Please write it down. Principle of superposition. Again, because of the Earth's gravity, that means Earth pull towards it, deposition of sediments will always be deposited. Please listen, this is very, very important. With older layer at the top, younger at the older layer at the bottom, younger at the top. For example, you are pouring sand every day from Monday to Friday. So first layer of sand poured, second on top of it, third on top of it, fourth on top of it, fifth on top of it. So this is how it goes. So it is called principle of superposition, where one layer of rock is deposited, one layer of rock is deposited. Just remember, one layer of rock is deposited. The next layer come after that, followed by another layer, followed by another layer. Okay, got it? And the new one will be at the top, old one will be at the bottom. But students, in the field, when you go out with Professor Sen, always don't be so lucky that you will find old rocks at the bottom and young rocks at the top. I'm just going to show you this picture now. This is Grand Canyon. In Grand Canyon, it has been seen that this layer of rock is old, which it should not be, right? It should be new. And this layer of rock is new. Why do we have old rock at the top and new rock at the bottom? Why will we have that? Old rock at the top and new rock at the bottom. This is because of the fact there is a total upliftment that happened after these rock layers were deposited one after another. Just remember, this is called the principle of superposition, according to which old layer should be at the bottom, new layer, old layer should be at the bottom, and new layer should be at the top. But in many cases, in the field, we have seen opposite things have happened, where old layer is at the top, new layer is at the bottom. That means we have to imagine that some form of upliftment has happened, or some form of tectonic movements have happened over here. Okay, done? Next is same thing over here. Next is principle of baked contacts. Principle of baked contacts. Now, this layer of rock, okay, let this be A. This is B. This is C. This is D. Can you layer it? Can you tell me from oldest to youngest? Which layer is the oldest here? Type it. Which layer is the oldest here? A, B, C, D. D is a pluton. What is a pluton? Any magma intrusion from beneath. A is the oldest, Mandy said. Correct, Mandy? Next to A, which is the next layer? Okay. Other students also please participate. Which is the next layer after B? No, D is not after A. I'm just going to tell you why. A after A is B. After B is C. Very good. After B is C. Actually, no. Okay. I'm going to show you. Please look very carefully. Layer A was formed. Okay. Layer B was formed. After this magnetic intrusion came. That means suddenly magma started to come. So it can only come where there is rock. That means C was not there. That's why it cannot go any further. C was not there. It cannot go any further. It stopped. So maybe after A, B, D, layer C was formed. So it is A, then B, then D, then C. Let's check whether you understood it or not. Yes or no? Kristen said yes. Other students, please tell me. Ray, Kristen, rest of the class. Okay, Kimberly, Brandon, rest of you. Rest of the class. Rest. Okay, all right. So this is called baked contact. That means an igneous intrusion, which is D, pluton. Hooks means it flows to an invaded country rock. What is a country rock? A, B, C, shale, limestone. It's called a country rock. The baked rocks must have been there. If the rocks are not there, whom can it bake? Bake means you see the sides of this rock. It has, if you see the sides of this rock, it has changed. Wait, I'm going to make it clear. Then, yeah. So look at this. The sides of the rocks have changed in composition. It's white in color. Sides of the rocks have changed in composition. It is white in color. And anyway, so it can only be changed when the rocks are formed. So Pluton came later on. Rocks were formed before. So A and B, and then the Pluton C. Okay, so we have principles. The first was principle of original horizontality. Then we have the original horizontality. Then we have the second one, which is called principle of superposition. Then we have the third one, which is called principle of baked contacts. And now we are going to do a little bit of work now. So we understood this problem that A was formed, then B was formed, then C was formed, and then came D. So now next one is, let's look at this diagram. 1, 2, and 3. Let's look at it. 1, 2, and 3. And tell me from old to new. So again, dikes are igneous intrusion, magma intrusion into the existing rock body. So rocks are already formed, and then suddenly from the magma chamber, some magma can come out anytime. Okay, there is always cracks in the bottom of the earth, under the earth's crust. Okay, so now look at it, dike 1, 2, and 3. Which is the oldest, which is the new? Please mark it. Oldest to new. Dike 1 oldest, raise it. Everybody agrees with him? Dike 1 is the oldest. Okay. Next, okay. Yes. So because dike 1 has been cut by dike 2, so definitely it is the oldest. When 2 can cut 1, that means 1 is already formed. Next. Which is the next dike? 2. Very good. 2 is the next dike. Then 3 is the youngest because nobody has cut 3. Dike 1 is cut by dike 2, dike 2 is cut by dike 3. So dike 1 is the oldest, then dike 2, then dike 3. Okay, you got it. You guys rock. Okay. Next is physical principles. Principle of inclusion. Please write it down. This is number 4. So we did principle of original horizontality, then principle of superposition. Number 3, principle of bake contacts. Number 4, principle of inclusion. Okay. So principle of inclusion says any rock fragment within another rock fragment, if it is found, then the rock fragment which is found is older. So please look at this very, very carefully. We call them xenolith. So these are small rock fragments. These are found in this particular rock. For example, this is sandstone. Okay, so this is sandstone, and there are small rock fragments which are called xenolith. There are small rock fragments which are called xenolith here. Okay, these are found inside sandstone. That means these are older. Okay, so these are older. Okay, everybody understood? So the rock fragments are older. Everybody got it? Yes or no? Very good. Okay. Next is principle of fossil succession. So we did principle of superposition, principle of original horizontality, principle of superposition, principle of bake contacts, principle of inclusion, and then principle of fossil succession. So this is number 5. I'm going to give you an essay to prepare for your final exam. Absolutely important. So please make a note of it and please write it down. Principle of fossil succession, number 5. Okay, write it down. Principle of fossil succession. So now, students, if you remember, we did Earth's history based on these fossils. Okay, we did it based on these fossils. Now, if I find a rock which is a fossil of, listen very carefully. So scientists always do not carry instruments to find out the age of the rock, but we want to know which period or which aeon or which epoch the rock belongs. That's our curiosity to know it. But we don't carry instruments in the field. I brought a rock from India. I really wanted to know the age because I found basalt on top of a mountain, and I was curious to know basalt, which should be under the ocean, why it came on top of a mountain. Students, in order to find the rock, I sent it to Virginia Tech. They said $1,500 for one small sample. How much money can I afford if I have like 100 samples? That's going to be too expensive. So scientists sometimes work with fossil. They want to see whether fossils are there in the rock and what type of fossils are there, and they try to determine the age of the rock through fossil formation. For example, I'm just going to show you. If I have a piece of shale in my rock box, 1 second. Okay, I don't have that good shale. Anyway, so some shales have fossils. Sedimentary rocks mostly has fossils. So scientists, what they do, they go through the fossils and they try to find out the fossil belongs to which age. We will do this lab today. Look at this. If I find the age of a fossil of a fish, I will try to understand that the rock belonged to this particular age, which is about 444 to 359 million years. Don't say no or yes to me and in understanding this, because this will be today's lab. So if you find a fossil which belongs to the Silurian period, you know that the rock is about 420 million years old. So through understanding of the fossil, scientists try to name or age the rock. Through the understanding of the fossil, scientists try to put an age in the rock. Okay, so this principle is called the principle of fossil succession. This principle is called the principle of fossil succession. So that is the last principle I want to talk about in this. So this is called principle of fossil succession. This is widely used in order to understand the rocks, because all sedimentary rocks have fossils, and fossils are time markers. We call them time markers of any events for relative dating. So I save a lot of money and lot of my resources in studying. I study fossil and try to put it in the fossil chart and tell that this rock belongs to that era. So remember something, fossils speak of past depositional environment. Fossils speak of past depositional environment, and specific fossils are found only at a particular time, right? And I know the fossils of dinosaur, I cannot say the rock was formed yesterday because there was no dinosaur. When I found dinosaur, I know this is the time it was formed because this dinosaur belongs to a Jurassic period. So here in this particular area, just remember that always, paleontologists, archaeologists, they work together in a particular field when they find this type of fossils. Okay, so I'm not reading it out. So fossil range, just remember, we try to find out the range of the fossils. So this is what we are going to use today. Just remember. So a scientist is working, and suppose he finds out, he dates a fossil. This is a fossil of the oldest, and it goes on to the youngest over here. You can we can find it. So if we put an arrow, we will see that this belongs here, and this fossil belong here. Look at that. Okay, so we make then we find another fossil, and then there was no upliftment that has been found. The rocks are beautifully layered in a superposition process in original horizontality. So we try to find out the age of the fossil. We see that in layers and the age of the rocks. Okay, now everybody understood these 5 principles? Yes or no? Tell me. Yes or no? Difference between relative age, absolute age, and the 5 principles. All of you understood it? Okay. All right. So let's take just a 10 minutes break, and we are going to come back at 3 p.m. And I'm going to do the next part of this, which is unconformities. What is unconformity? Okay. At 3 p.m. Right at 3 p.m. We'll come for unconformities.